So, a very good morning to all of you. Hope you are all fine at your places. Today, we will start the another topic, or rather, you can say that we will start the another unit of power station practice. And this unit is basically known as electrical tariff. Tariff means the amount that you give to the PDD department for consumption of electricity. In simple word, I can say. So in this chapter, we will discuss that what are the various types of load occur in our power system. Accordingly, there are different types of tariffs occur in a system. We have discussed about the load curves. What do you mean by the load curves? What are the variable load? What is a peak load? What is a base load? And certain other units or terminologies that we can use in our tariff. Before discussing tariff, we have to discuss that what do you mean by this one unit? Because electrical department, or you can say that your power development department, PDD department, when create a electricity bill for you people, and you have to pay that bill, and the payment that you had given to the PDD department is known as tariff. So first of all, you should know that how this tariff can be calculated, and what is the rate of 1 unit of tariff. So before discussing the rate of 1 unit of tariff, you must all know what do you mean by this 1 unit. See, everybody has a energy meter. That energy meter will be installed in your house, and this energy meter is continuously recording the energy consumption by you people at your residence. After 1 month, there are certain units that will be traced on this energy meter, or you can say that this is called as the reading on an energy meter. And depending upon the cost of 1 unit, your electricity bill will be made, and this bill will be dispatched to your home, and accordingly you have to pay that electricity bill, and this is basically known as electrical tariff. Okay, so you must all know that the electrical tariff is basically the amount that you had to pay for consumption of electricity, and the consumption of electricity is always be in uh, units, and 1 unit is basically equal to 1 kilowatt hour. That means if your load of 1 kW, 1000 watt, work for 1 hour, then your energy meter will record 1 unit reading. And if the rate of 1 unit is around 3 or 4 rupees, then you have to pay the electricity department 3 or 4 rupees per hour. Okay, now let us take an example, that is how this tariff can be made and how you can calculate this tariff. We will discuss in our next lecture that how this electricity consumption can be calculated and what is the actual tariff rate you can get it. So we will take an example that, for example, let it be we have a one lamp of 100 watt installed in your house. I can again repeat. Let us take an example. One lamp of 100 watt is installed in your house. Then this lamp is working for 1 hour a day. That means your electric consumption will be 100 watt hour. And the units for, you can say that units for your electricity or the energy consumption is basically 1 kilowatt hour. So that means you can say when a unit, when a lamp having a capacity of 1000 watt is working for 1 hour in a day, then your energy meter will record a reading of 1 unit. And if the rate of rate of 1 unit is approximately 3 or 4 rupees, then your electricity bill for a particular 1 hour or particular day will be 3 and 4. And if you multiply it with number of days in a month, you can get your electricity bill. Is it clear? So in our next lectures, in our next presentations, we will see that how this electrical tariff can be calculated, how the different types of load has different criteria for the electrical tariff. Okay, ji. Again, before discussing this electrical tariff, this is the basic structure of your electrical system that I had already discussed with you people when we start our power station and practice. The basic power system consists of the three main important things, that is called as generation, your transmission, and your distribution. So in this diagram, you can see your black color diagrams will represent generation part, your blue color lines will represent the transmission part, and your green line represents your distribution part. So here, from the generation level, electricity will generate depending upon whatever the generating station you can use. You can use a solar, you can use a hydro, nuclear, thermal, geothermal. All the generating stations can generate electricity. How? In all the generating stations, one form of energy is converted into electrical energy. After that, we will discuss in our previous lecture, this generation electricity at a certain level of voltage will step up with the help of step up transformer. And after this step up transformer, it will be transmitted with the help of certain transmission system that comprises of poles, structures, conductors, insulators. And this high power voltage can be transferred to a grid station, and the grid station can receive the power at a very high voltage. And in a grid station, it will start step down to a certain level, and after that, this step down voltage will again transfer to the near substation with the help of some you can say that secondary substation systems. And after that, we can receive the power at our load center. So when you combine your generating part, your transmission part, your distribution part, the whole of the system so obtained is called as power system. Now in this power system, there are different types of load occur. And you see in our in our future lectures that every load has a different tariff formula. Every load has a different technique for calculating of the tariffs, and these all tariffs is ultimately dependent upon the, the loads. For example, in our electrical, there are different types of load occur: domestic load, commercial load, industrial load, municipal load, irrigation load, traction load. Now, the rate of tariff for domestic load is obviously different from commercial load, different from industrial load, different from municipal load, and all that. And likewise, the rate for 1 unit of electric consumption, which is known as electrical tariff, is different for domestic, industrial, municipal, irrigation, and traction. So you can say that every load has different tariff rate. Understood? The rate for consumption of electricity in domestic load never met or never meet with the industrial load. The rate of electricity consumption with industrial load is never met with municipal load, irrigation load, and traction load. Is it clear? Up till anybody having any doubt, he or she can ask me, or otherwise I will continuing it. Yeah, tell me.
No, sir.
Shall I continue?
Yes, sir.
Okay, fine. So you see in our coming slides that every load has different criteria for the different loads that we will discuss one by one. That is how these loads are to be calculated, and what are the various rate of electricity consumption on the different loads. This is one of the most important term that occur in our power system. That is called as variable load on the power station. What do you mean? The load on the power station always and always varies from time to time due to uncertain demands of the consumer, and that is why this is known as variable load on the station. What does it mean? Mean throughout the day, throughout the 24 hours in a day, your load demand is never constant. It will rise increasing for a certain time, and it will start decreasing for a certain time. So you can say that throughout the day, throughout the 24 hours in a day, your load is not a stable. Your load demand will suddenly increase, suddenly decrease, suddenly become flattered, suddenly become saturation. So you can say that always and always there is a challenge on the power system, that there is always a variable load occur in the power station, and this is one of the most and most important challenge for the power system engineers, because the effects of the variable load means need of additional equipment and also increase in the production cost. For example, if we take the example of a particular day, we will start calculating the load on a particular date from 12 midnight to next day 12 midnight. So you see, from 12 midnight to almost in the morning 6 to 7, there is not a high load, there is always a small load occur in the power system. Now at that time your commercial load is equal to 0, because from midnight 12 to the morning 6 or morning 7, all the commercial buildings, all the commercial executions are not working. So in that case their load will be equal to 0. But at that time your domestic load will increase, and when you see from morning 6 to 12 noon, or from morning 7 to 12 noon, this load is changing. Now the domestic load will decrease, and on the another hand your commercial load will start increasing. And at the same time, this is the time when also you can say that your industrial load is also start increasing. Now from 12 noon to say around again 6 evening, your commercial load will be at high, at a peak. But at this time your domestic load will be almost equal to 0. The reason being, all the human beings that are present in our houses, they are working in some offices, some outside, so their domestic load will be equal to 0. But from 12 noon to 6 p.m. in the evening, there is a peak or the high load in the commercial loads, and at the same time the industrial load is also very very high. Now after that, if you take from 6 to the evening, from evening 6 to the evening 10, your commercial load is also there, but in addition to that thing, your domestic load is also included, because you are returned back from your offices to the homes, and but obvious, when you return you to your homes, your domestic load will start increasing. So from 6 evening to the 10 evening, both the loads are will be executed, and from 10 to again 12 midnight, your commercial load will be equal to 0 and your residential load will start increasing. So you see, we will take only one example for a particular day, and you see on that particular day from 12 midnight to another day 12 midnight, your load will not the same. That load is always, you can say that, changing. That sometime one load is high, another load is low, another time another load is high and same load is low. So all the time in that power system your load will not remain same, and that is why this is a called as a variable load. And this variable load, I can again tell you that this variable load is basically a real challenge for the power engineers that to be working on the generating stations, because when the load is increasing, then you have to get another equipments in parallel with the normal running equipments, and also the production cost will increase. So you can say that I am again telling you that all the day your load on the power system is not constant. It will always and always it will be becomes as variable. So what the power system engineers do, or what the PDD department, power development department do, he or she can calculate a curve, and that curve is basically called as load curve, as you seen on your screens. This curve shows a variation of the load on the power station with respect to the time. So you can see that on an x-axis there is a time, that is 12 midnight to 1 midnight, 2 midnight, 3 midnight, 4 midnight, 5, 6, 7,
Yes.
8, so on, throughout the day. And on the y-axis, there is a consumption of electrical load from 13,000, 14,000, 15,000, 16,000. And you see from this load curve, from 12 midnight to the next day 12 midnight, these are the various curves that you can obtain. So this is basically called as a load curve. Now, what does power engineers or the PDD department engineers do? Firstly, they made this load curve on a daily basis. For example, if we count the year 2020 in the month of October, the very first October, the power engineers made this load curve. On the next day, 2nd October, also made the load curve. And this third day, 4th, 5th, 6th, so on, then so on to 30th October, they all made the load curve. So you can say that on the basis of daily load curve, the power engineers made monthly load curve. After getting the monthly load curve, he or she can get an idea that what is the average load occur in the month of October. On the basis of that thing, what they do, they frame the load curve on quarterly basis. Means every 3 years, every 3 months, they made a curve, and this curve is called as a quarterly load curve. After that, average will be taken out, and biannually or half yearly load curve will be made, and after that yearly load curve will made. And after the yearly load curve will maintain, the power engineers get an idea that what is exactly occur in a power system, and they emphasize that every time the load will change in the power system. So, depending upon the load utilization by the consumer terminals, every 5 years of plan, there will be need to enhance the, you can say that, production, enhance the transmission, enhance the distribution. New generating stations can be created, new substations can be created, new grid stations can be created, so that they met the power requirement in a day. You must notice that the consumption rate of electricity now we are taking is very high as compared to if you go a 5 years back or a 10 years back. I will just quote an example. If you go a 5 years back or a 10 years back, I think in all the locality there are only one or two air conditioners. But nowadays every house is having one or two air conditioners. So means every day your consumption rate of electricity is increasing day by day, day by day, day by day. That means you are consuming the electricity day by day, day by day, day by day. But from where this electricity you can get? If you consume this electricity day by day, you have to also generate that amount of electricity. And how much amount of electricity that can be generated, it is only calculated on the basis of this load curve. So I think with this load curve you can get an idea that what do you mean by the variable load on the power station and how these load curves can be obtained. Anybody having any doubt or anybody having any question up till stage?
No, sir.
So shall I continue next?
Yes, sir.
Okay, fine. So after you can say that the load curve. Now the load curve has certain importances. What are the importances of this load curve? The daily load curve gives the information of the load on the power station during different running hours of the day that I had already explained to you. The number of units generation per day is found from the area under the load curve. Average load is always found from the load curve, and the average load is equal to area kWh under the daily load curve divided by 24 hours a day, because already the load curve can be made on a basis of one day. Maximum demand on the station on that day is found from the highest point on the daily load curve. The size and the number of generating stations can be determined by the load curve, and this load curve helps us to determine the operation schedule of the station in that case when all the units or less units need to running is found. So these are certain importance of the daily load curve. Now, based upon the daily load curve, we also made a load duration curve. Now, what does we mean by this load duration curve? When the load elements on the load curve are arranged in the order of descending magnitude, the curve so obtained is called as load duration curve. That means this load duration curve is obtained from your daily load curve. So you see on a x-axis you have a time 0 to 3 hours, or you 0 to 3, that is 12 midnight to 3. After that you have 3 to 7, 7 to 12, 12 to 16, 16 to 24, and on the y-axis you have 5, 10, 20, 35. You can see from 0 to 3 there is a peak load, and that peak load will be 80. After 3 to 7 the load will start decreasing, the load will become 35. After that the load will be 20, after that the load will be 10, and after that the load will be 5. So on the basis of daily load curve we can formulate the load duration curve, and this load duration curve is nothing, it is when the load elements on the load curve are arranged in the order of descending magnitude, the curve so obtained is called as load duration curve. Clear ji? So this is all about what do you mean by the variable loads on the power station, how the load curves can be obtained, what are the importance of load curve, and how the load duration curve can be obtained from your load curve. So this is all about for the today's lecture. We will meet on tomorrow at our scheduled lecture and discuss the some of the important terms and the factors and the interrelations that we can use in power system in the terms of tariff. Fine. So anybody having any doubt, he or she can ask me or put me the message. Okay, fine.